This is Algebra 2. We are reviewing lessons 1.1 through 1.4 with this sequences where we're going to sort and solve. There are 8 different scenarios here, A through H, and there they all are. With each of these scenarios, we are going to determine whether or not they are arithmetic or geometric. We're going to find either the common difference or the common ratio. We're going to write a recursive formula, an explicit formula, and if it is an arithmetic, if we were circling this one, then we're going to find the sum of the first 21 terms. All right, so I'm going to have to flip back and forth a few times. Let's read A. And this video is intended to be a solution video and also a way to look at hints if you're just trying to get a little bit motivated. Part A, Mallory's New Year resolution is to become a better runner. Due to the frigid Michigan temperatures and her extreme commitment to her studies, Mallory is unable or unmotivated to start working on her goal until school gets out. On June 1st, she starts by running 15 minutes, and every day after that, she adds 5 minutes to her run. All right, so the fact that she is adding here means that we are probably arithmetic, because arithmetic constantly adds over and over, whereas geometric multiplies or divides over and over. So let's go ahead and go to scenario 1, and you'll be writing on a blank piece of paper like I am. In scenario A with Mallory, this is going to be arithmetic because we are adding. And for number 2, the common difference, you're constantly adding 5, so I'm going to say plus 5. The recursive formula, she started by running 15 minutes. So I'll say on her first day, a sub 1 was equal to 15. And then the recursive formula always says a sub n is equal to something, right? We take the previous term, I'm going to zoom in here so I can write better. We take the previous term, n minus 1, and then we add 5 to the previous term. So add 5. Excellent. And for the explicit formula, again, we're going to have some a sub n. And we're going to choose whichever term we want. In this case, I'm going to choose the first term and put it down here. So we're going to choose 15, and then we add the common difference, plus 5, and then we multiply by n minus whatever term we chose. We chose the first term, so this 1 is going to come down here. We're going to say n minus 1. All right, and check it out. We were arithmetic, so we do indeed need to do this one. We need to find the sum of the first 21 terms. The way that we do that is we look at the first term, the 21st term. So we need to find a sub 1, which we happen to have is 15. We need to find the 21st term. We need to find a sub 21. You always find the first and last terms. Well, how do I find the 21st term? I'm going to use this formula right here. I'm going to pull it down here, and I'm going to say that this is 15 plus 5 times what minus 1? I'm going to plug in n minus 1. So this is 21 minus 1. It's going to be plugged over here. 21 minus 1. And what is that going to be? It's going to be 15 plus 5 times 20. 5 times 2 is 10. Add on an extra 0 is 100. So this is going to be 15 plus 100. This is going to be 115. So remember that to do a sum, what we do is we do the number of pairs, so n divided by 2 is the number of pairs, and we multiply that by the first term and the last term. So this is going to be a sub 1 plus a sub n in this case. So here's our formula. We take 21 terms, so 21 terms, and we're going to do the first term, 15, plus the last term, 115. And I think for all of these, I'm just going to plug them into the calculator to just go a little bit faster here. We have a lot of these to do. I don't want to take up too much of our time. I'm going to move the calculator to the left, make it slightly smaller so I can still write. So I'm going to do 21 divided by 2, and this is all going to be multiplied by 15 plus 115. And that's going to be equal to 1,365. All right, we're moving on to our next scenario. We'll come back to that calculator when we need it. Let's go ahead and read. Zoom out here. Okay, Joan joins a yoga club. It costs $15 to join, so that sounds like a starting amount. So I'll label that my start amount. So remember, start at 15 again, just like this 15 was also a start amount. $15 to join the club, and any class she takes will cost an additional plus 6. So this to me sounds like you're constantly adding 6, and if you're adding 6, that means you're doing the common difference, and this is arithmetic. Okay, I can remember that. It's very similar to the last one. Instead of start at 15, add 5. This one starts at 15 and adds 6. It's basically the same thing. So in Jones, we have, this is also arithmetic because we're adding. The common difference in this case, not the common ratio. Did I circle difference? This was a common difference, not a common ratio. This is the common difference, not the common ratio, is this time plus 6. So what's our recursive formula? Again, our first term, our a sub 1, is equal to 15. And to find the next term, we take the previous term, a sub n minus 1, and we just add 6 to it. Again, remember, recursive formulas always have two parts. Explicit formulas just have one part. We say a sub n is equal to, we'll take the first term, and this is going to add the common difference, plus 6. And then we're going to multiply by n minus whichever term we chose. We chose the first term, so we're going to plug a 1 in down here, n minus 1. All right, this is, again, an arithmetic sequence, so we are going to add the first 21 terms. So here we go. We need the first term, and we need the last term. The first term we have, the first term is 15. We do not have the last term, so we're going to use our explicit formula to jump straight to term 21. We're going to say this is 15 plus 6 times, in this case, n is 21 minus 1. I can do that pretty quickly without a calculator. This is 15 plus 6 times 20. I don't know why there's an equal to sign here. That should be a plus sign. 15 plus 6 times 20. This is going to be equal to 15 plus 6 times 2 is 12. Add on the 0. This is going to be 135. Okay, and then I'm plugging into that formula where you take the number of pairs, n divided by 2, and then you multiply that by those rainbows, which is the first term plus the last term. So in this case, this is going to be 21 divided by 2 times, and then the first term is 15, the last term is 135, and again, I'm just going to plug this into my calculator to see what I get. So pull up my calculator, so we can go over to the left-hand side. We get 21 divided by 2, and this is going to be multiplied by 15 plus 135, and I get 1,575. I have a feeling that at some point in this video I will make a mistake. If you catch a mistake, it's extra credit. I don't have an answer key in front of me. I'm just doing this to the best of my abilities early in the morning. All right, let's jump into our next problem. Problem C. So Mrs. Gallus likes writing lots of exam questions. She usually starts out the semester with only 10 questions, and it even has the word start here. So you start with 10. So 10 is our starting round. But for each subsequent exam, so the next exam, she writes, and I'm using advanced vocabulary, this just means next. Next. For the next exam, she writes 1.5 as many questions as were the previous exam. So you don't add 1.5 and add 1.5. You can't add half a question. I don't think you can, but maybe you can. She writes 1.5 as many questions. When you see the word as many, that usually means multiply. So as many is multiplying in this case. And this is 1.5, so 1.5 is being multiplying by 1.5 over and over. So this is a case where down here we are geometric because we are multiplying. So that means we're doing a common ratio. We're not doing a common difference, and that common ratio is multiplying by 1.5 each time. All right, so let's find our recursive formula. So our starting term, in this case, she started with 10 questions. So our first term is 10 questions. And then to find the next term, our recursive formula, a sub n, is going to be equal to the previous term, a sub n minus 1. And we're going to multiply by 1.5. Again, if you like using fractions, you can say 1.5. But I typically don't like mixed fractions. I like decimals if I have to mix numbers. All right, time for the explicit formula. So I'm going to have an a sub n. I always have this, whatever, I can choose any term I want. I'm choosing the first term because I already have it right here. This is going to be 10. And then I'm going to always multiply. Again, notice the commonality between all of these. So whenever we were doing recursive where we're adding 6, then this is going to be adding 6 right here. Adding 6 in the pattern is adding 6 in the explicit. Multiplying by 1.5 is going to be multiplying by 1.5 also in the explicit. So I'm going to multiply by 1.5. And to do that repeatedly, we need to have some power up here. So this is going to be the power of n minus something. Well, which term do we choose? We chose the first term, so this is going to be an n minus 1. All right. From here, I'm ready to jump down to the next one. If arithmetic, it's not arithmetic, it's geometric. And geometric have a way to add them all up, but we haven't learned that yet, so we don't have to do part 5, so we can cross that one off. All right, we're moving on to scenario D. In a golf tournament, 16 golfers with the lowest scores win cash prizes. So 16 is a quantity, so usually that's our final amount, or n number. First place receives $1,000. Second place receives $950. Third place receives $900, and so on. Ooh, okay. So this is kind of like the starting number. This is for n is equal to 1, we get $1,000. And then when n is equal to 2, we get $950. When n is equal to 3, we get $900. Interesting, okay. So it seems to me that we are, to get from 1,000 to 950, we are going down 50. To get from 950 to 900, we are going down 50. We're constantly going down 50, down 50, down 50. Whenever you add or subtract, that's going to be arithmetic. So it sounds like we're starting with 1,000 and going down 50 over and over, and then we're doing that 16 times. Okay, so far so good. And I think in this problem, I'm going to maybe change my, I haven't read these problems before assigning the work, I'll admit that. So instead of finding the sum of the first 21 terms, I'm going to find the sum of the first 16 terms. So let's go ahead and do that over here. In part D, I'm going to obviously choose arithmetic because this is constantly adding or subtracting. In this case, we are subtracting. So this one will not have a common ratio, it will have a common difference. The common difference, you're constantly going down by 50, minus 50. All right, time for our recursive formula. What number did we start off? Well, the first place got $1,000, so a sub 1 is 1,000. And to find the next one, you do a sub n, you take the previous term, a sub n minus 1, and you're going to subtract 50. Okay, this one, I'm already looking ahead, this is going to be 16 terms. For our explicit formula, we are going to do a sub n is going to be equal to some, I could choose second place or third place. I'm going to choose first place because I think most people probably chose first place. And we are going to subtract our common difference, and then repeated subtraction is multiplication. So this is going to be multiplied by n minus, well, which term do we choose? We chose the first term, so this is going to be n minus 1. All right, I have a feeling that some people didn't look at the video in advance, so they probably still did the first 21 terms. I'll do both of these. This one that makes sense and this one that you might have already done, so you can check both. But this one makes more sense, so that's one I'm leaning towards. So this is arithmetic, so check. So we need the first term, we need a sub 1, and we need, well, that's 1,000. And we need the last term, in this case, a sub 16. I'll do 21 off to the side, but this one is one that makes sense. So the 16th term, I'm going to plug that into our formula again. So this formula is going to come down here and help us. We're going to say that this is 1,000 minus, oh, that's 100. This is going to be 1,000 minus 50 times 16 minus 1. And that's going to be equal to 1,000 minus 50 times 15, and I'm seeing multiplied by 3 multiplied by 5 is really the steps for 15. So if I multiply this by 5, I get 250. If I multiply that by 3, I get 750. So this is really equal to 1,000 minus 750, and that looks like the last place gets, the 16th person gets $250. I think that's correct. I'm starting to doubt my math, and I know that I'm going to need to calculate it anyway, so I might as well pull it up now. Let's make sure that I've been doing this correctly. I like writing on the right-hand side because I'm right-handed, so that's why I'm moving the calculator off to the left. Let's just calculate 1,000 minus 50 times 15. Okay, I did get it correct. And while I'm here, I might as well calculate a sub 21 in case you did that as well. So that's going to be 1,000 minus 50 times 21 minus 1. And that's going to be 1,000 minus 50 times 20. 5 times 2 is 10. Add on the extra 0, 0. Oh, that's exactly 0. Let me show my work. This is 1,000 still, minus 5 times 2 is 10. Add on the 2 zeros, and then this is going to be 0. I didn't even look at the problem, but the first 21 terms make a lot of sense in this problem. All right, so let's go ahead and find the sum of the first 16. And the way that I do that is I'm going to do 16 divided by 2 to find the number of pairs, then multiply by the first number, which is 1,000. I made a typo there. If you caught this one up there, you can give yourself some extra credit. It's going to be 1,000 for first place, and then the 16th place is 250. And I'm going to just do this on the calculator. 16 divided by 2 is 8. So I'm going to multiply that by 1,250. And you get, holy moly, that is a lot of money. $10,000. So that's 10 with 3 zeros. Okay, what if you did the sum of the first 21 terms? So instead of doing S of 16, what about S of 21? What would that be? Well, the sum of the first 21 terms is 21 divided by 2 pairs, and then you multiply that by the first term, which in this case was 1,000, plus the last term, which was 0. So I'm just going to do that one, 21 divided by 2, and then I'm going to multiply this by 1 with 4 zeros, 1, 2, 3, 4, and that is equal to 10,000, or 100, no, is that right? That seems too much. 105,000. That means one of these was wrong. What did I do that was wrong? Yes, I did too many zeros. There we go. Okay, I was looking at the calculator, trying to find my mistake. 10,500. Because it should still be about 10,000. It's just adding on an extra little bit at the very end. 10,500. So you have both of those. This is the one that I officially asked for in the instructions. This is the one that makes more sense in our scenario. All right, we're moving on to situation E. So I have to come back all the way over here. In E, there are 16 square tiles on the path from Little Red Riding Hood's house to her grandmother's house. On the first tile, Little Red drops 3 crumbs. Okay, that sounds like a starting amount to me, so I'm going to go ahead and annotate U and say this is our start amount. We're starting on 3. So that's when, on the first tile, that's when n is equal to 1, as opposed to n is equal to 0. So I do want to keep track of, we're starting at 0 or 1, right? We're starting at 1 in this case. All right. On the second tile, Little Red drops 6. Okay, are we adding 3 or are we multiplying by 2? I don't know yet. On the third tile, she drops 12. Okay, so to get from 6 to 12, we're not adding 3, we're adding 6. So you add 3 and add 6. Those are not common differences, so you must be doing something that's geometric, I assume. So to get from 3 to 6, I think I'm multiplying by 2, and from 6 to 12, we're also multiplying by 2. So I can already tell here that we're going to have some sort of common ratio. The common ratio is going to be multiplying by 2. All right, and so on and so on. Okay, so we're starting at 1 and multiplying by 2. That's what I'm taking away from this problem, and it's geometric. So let's go to E and fill that in. In E, we are geometric. We have a common ratio, not a common difference, and I want to say that the common ratio is 2, technically because we're multiplying by 2, right? You don't actually have to have the multiply symbol in here whenever you're doing common ratio. I think I've been doing a bad job of doing that, so bad, Mr. Sindel. Technically, I mean, this one you did have to have a negative because it's a negative 50. You're adding a negative 50. These ones I technically didn't have to have a plus 5. 5 is fine. 6 is technically fine. Multiplying, you never want to say multiply when the common ratio is 1.5. I need to be more exact in how I phrase things. So the common ratio is 2. That's exactly how you phrase it. All right, so I remember that in Little Red Riding Hood's case, she drops 3 on the first cake, right? I think it was 3. She didn't drop 1. Yeah, it went from 3 to 6 to 12. That's right. Okay, so our first formula, the first tile, she had 3, and then from there, to get any subsequent tile, this is going to be take the previous tile, a sub n minus 1, and you just multiply by 2. 3 times 2 is 6, 6 times 2 is 12. Okay, everything there makes sense. So the explicit formula, a sub n, you take any number that you want. So I'm going to take the first number, in this case 3, and you're going to multiply by 2. And then repeatedly multiplying means we're going to come up here to the power. This is going to be 2 to the power of n minus, okay, which tile did we choose? We chose the first tile, so this is going to be an n minus 1 in this case. So far, so good. All right, and this is not arithmetic, so we don't have to do number 5. This was geometric. Again, I will warn us that there is a way in this unit that we will add up geometric sums, but we don't know that yet. Excellent. All right, we're on to scenario F. All right, we've got the Wilcox family is heading out west on a trip following the I-90 west. Mr. Wilcox wants to take his trip, take his time on the trip, I can read. They start at EKHS, which is some sort of high school, and travel 350 miles on the first day. Okay, that sounds like a starting amount. So 350, that's our start. And that's the start when our time or our day, D, whatever, I'm just going to say N in this case, when N is equal to 1. That's the first day. On the second day, they drive a percent. Okay, this is kind of a key that you should take away for tomorrow's quiz. Anytime you see a percent, that automatically means it's geometric. So this automatically means it's geometric because it's a percent. Percents have to be multiplied. If you say, what is 200% of 1? You do 200 as a decimal, 2, and then you multiply by 1. You always multiply percentages in some form or another. Okay. So we know it's geometric, which means we're going to be multiplying by some amount. What is the amount that we're multiplying by? Well, if we're only driving 80% of their previous day's mileage, then we're multiplying by 80%. If it said 80% less, then you would be subtracting 80%, but this just says they drive 80%. Like, they don't add or subtract, they just do this thing, which means you just multiply by this thing. There's no words that say more or less than. Just read that again. There's no more or less than. They just do this 80% compared to their previous mileage. And then on the next day, they just multiply by that percent. So I don't even have to do more or less. I don't have to do plus or minus. I just multiply by 80%, and I'm done. The problem with that is it's a percent and not a number. It's not a decimal. So I need to multiply by, let's move our decimal. It was here. We're going to move it 1, 2 to the left, and this is going to be 0.8. So I'll say that our common ratio here is 0.8. All right, have we done the full analysis of this? It doesn't say how many days there are, so it does make sense to do 21 days of traveling. Perhaps they're only traveling like 1/10 of a mile by the very final day. I'm not sure. Okay, so geometric ratio common ratio is 0.8. I think everything here is ready to go. Oh, and our start is 350. I'll remember all these numbers so I don't have to come back here. All right, we are on F, right? Yeah. The Wilcox family is F. So what do we have here? First of all, it's geometric because we have a percent. Therefore, we don't have a common difference, but we have a common ratio. And that common ratio, we don't say it's multiplying by, because when we say common ratio, you always assume it's multiplication. You can never assume division. And that is 0.8 or just 0.8. All right, so our recursive formula. What was the first day? On the first day, wasn't it like 350 or something? I think it was 350 miles, right? And then to get the next day, we just took the previous value. A sub n minus 1 means previous value. We took the previous value and we multiply by 0.8. All right, nice and easy. Explicitly, we do a sub n. We choose we'll choose the first value. So we'll bring 350 here down. We choose 350 and we multiply by 0.8. Again, it's kind of like we take this value and we multiply by that and we're done, but we need to repeatedly do that. When we repeatedly multiply, that's a power. So it's going to be n minus, and then this is the first term, so this 1 is going to come over here. This is n minus 1. All right, it was not arithmetic, so we don't have to do part 5, cross it off. All right, and then we have 2 more, right? G and H, and we're done. All right, let's go look at G. We've got Lindsay. Lindsay is working really hard to improve on Algebra 2. Good for her. On her first quiz, she scored 67 points. Okay, so this sounds like a start amount. So this is when n is equal to 1, because it says first quiz. That means n is equal to 1, right? So when n is equal to 1, she gets 67 points and then scores 71. So that's her second attempt. That's when n is equal to 2. And 75, that's n is equal to 3. her scores continue to increase at the same rate. So what rate is it doing? Are we multiplying? Are we adding? To get from 67 to 71, it seems like we're adding 4 to me, because I don't know how to multiply by something to get from 67 to 71. So I think I'm doing plus 4 to get from U to U. I think it's plus 4 again. Check it out. Yeah, so 71 plus 4 is 75. So I think we're constantly adding 4. I think that the common difference here is just a positive 4. So we know that she starts at 67 and adds 4. So far, so good. In this one, it doesn't make sense to add them all together, but I'm going to do it anyway because it's a good review on how to do summation problems. So we're all the way over here on part G. Part G was Lindsay, right? All right, so this one is arithmetic, which means we will have to do part 5. This one has a common difference and not a common ratio. That common difference, she was adding 4, right? Yeah, adding 4. I don't do plus 4, I just say plus 4. It's just 4. You always assume that's the number that's being added. You're either adding a positive or a negative. This one is a positive, so we don't have a sign in front of it. All right, recursive. So we need the first term. On her first test, she scored a 67. And then on all future tests, she took the previous test, a sub n minus 1 means the previous test, and then we just add 4 to it. And then for the explicit formula, we say a sub n, and this is going to be equal to, well, we need the any test we want. We can choose the second test, but I'm going to choose the first test because I have it right here. And then I'm going to add the common difference, and I repeatedly add the common difference, which means we multiply. Multiply by n minus, okay, which term do we choose? We chose the first term yet again. So down here, this is going to be the first term. All right, this is arithmetic, so we do need to find the sum of the first 21 terms, although that doesn't make sense because you don't add up all those grades together, unless maybe you're trying to calculate your total points that you get. But I think if we add the last term, you're somehow getting, Lindsay's getting like 150% on her test or something crazy like that. You're getting over 100%. So to find that, we need the first term, which we know is 67, and we need the last term. The last term is the 21st term in this scenario. And I don't know what the last term is, so I'm going to use this explicit formula to jump straight there. So I'm going to take 67 plus 4 times n is now 21 minus 1, and this is going to be 67 plus 4 times 21 minus 1 is 20. 4 times 20 is 80, so I have 67 plus 80. And 8 plus 6 is 14, so 14 with a 7 is 147. Somehow, by her 21st test, she's getting 147%. Good job, Lindsay. I really hope that... Never mind. All right, so we're moving on to finding the sum. So the sum of the first 21 terms is going to be the number of pairs. It's going to be, in this case, I'll do the general formula, right? It's going to be, general formula is n over 2 to find the number of pairs, and then the first term plus the last term. So in this case, it's going to be 21 over 2 times the first term, 67, plus the last term, which is 147. And then that is what we're going to enter to our calculator. So come back over here, pull up our handy-dandy calculator, throw it over here on the left so we can actually see what's going on and have room to write. So you go to a quarter of a screen. All right, we're going to do 21 divided by 2, and we are going to multiply that by 67 plus 147. Whew. All right, that is a big number, and I'm just going to write down that number and hope that I didn't make any too big of mistakes. So I got 2,247. Just out of curiosity, you've been doing that 21 times. What was your average score? If I divide that by 21, your average score now, Lindsay, is 107. I think you probably got an A+ after those 21 tests. All right, and we are on to our final problem, H. Once a week, Mr. Baker makes sugar cookies. I mean, how could you not make some sort of cookies? Your name is Mr. Baker. You've got to be baking something. Probably cookies, brownies, pizza. I don't know. You've got to be in the cooking business. Maybe you just own a paneria, right? All right, the first week he makes the recipe. He uses a full 2 cups of sugar called for. Good for him. I like sugary cookies. That sounds like a starting amount to me. Say 2, that's a start. And then each week after that, he reduces the... What is he doing? Why is he reducing the sugar? I don't know if I want to go to... Whatever. He reduces the amount of sugar by 1/3 of the previous week. So if I'm taking 1/3, am I subtracting 1/3, or am I multiplying by something that has a 1/3 in it? So we need to think about this carefully. if he's reducing by 1/3 from the previous week, it's not a consistent amount. For example, what if I start at, I'm just going to randomly choose a number, 47. If I start with 40, no, I can't start with 47. I have to start with 2, don't I? Okay, if I start with 2, 2 is really the same thing as 6/3. Why? Because I multiply the top and bottom by 3. I see what's about to happen here. If I go down by 1/3, I'm going to subtract 1/3 of 2. If I'm subtracting 1/3 of 2, I have to subtract 1/3 of 2, which means I have 6/3 and I'm subtracting 2/3, which seems okay. Yeah, you get 4/3, Mr. Sindel. We went down by 2/3. But in the next week, we need to go down by the previous week. So I need to do 1/3 of 4/3. And if I'm doing that, so for the next week, I'm going to have 4/3 and I go down by 1/3 of 4/3. That means I'm going to be doing 4/3 and I go down 4/9. So, and where did you get 4/9 from? 1 times 4 is 4, 3 times 3 is 9. This is 4/9. I went down by 2/3 in the first week and down by 4/9 in the second week. Does that look like a common difference? Am I subtracting the same amount over and over? And the answer is no, and it's because this is geometric. So I've proven to us all now, this is geometric, and we're going down by 1/3. So the fact that we're reducing means we are subtracting. Whenever you have subtracting, that means you're subtracting from 1. I have 1 and I'm subtracting 1/3, and that is the common ratio. R is 1 minus 1/3, so our common ratio in this case is actually 3/3 minus 1/3, and our common ratio is 2/3. We can just say it's 2/3. That is exactly what the common ratio is going to be. So just make sure you know the difference between F and H, because they're big differences. This one didn't say reducing or anything. It says you do this 80%, so that is the answer. You just say that's the answer. But this one says it's reducing by 1/3, which means you subtract that 1/3. You subtract 1/3 from what? You always subtract it from 1. From 100%, because if you multiply by 1, it doesn't move. But if I change the 1 just a little bit, then it does something. If I go down, it's starting to reduce, and if I'm going up, it's starting to increase. All right, so let's summarize everything here so I know what to write down. First of all, we start at 2. It's a geometric series, and the common ratio is 2/3. All right, done all the work. Just need to write it all down. Here we go, Mr. Baker. All right, you are geometric. Why? Because we're multiplying by 2/3 each time. We do not have a common difference, but we do have a common ratio. And the common ratio here is R is equal to 2/3. And again, the way that we got that, and I'll write it down again here, we got 1 minus 1/3, which is equal to 3/3, minus 1/3, which is equal to 2/3. All right. The recursive formula. I mean, I think this was probably the hardest bit, knowing how to get to 2/3. Once we know that, it's pretty straightforward. You just multiply by 2/3. We say, hey, the first amount of sugar for the first day is 2, and then every term after that can be found by taking the previous term, which means n minus 1, and we just multiply by the common ratio of 2/3. And the explicit formula, we say, yes, a sub n, take any term we want, 2 in this case, and you constantly multiply over and over again by 2/3. And as a shortcut of repeated multiplication, we do this to a power. What power? To the power of n, and I'll take all of this to the power of n minus, well, which term do we choose? We chose the first term, so it's going to be n minus 1. And check it out, this was a geometric, therefore not arithmetic. Cross off arithmetic, cross off number 5, and we are done with our review. So that concludes this very long video for our review for lessons 1.1 to 1.4 for Algebra 2. Thanks for watching. Be ready for the quiz next school day.